Guys, so we're going to continue. So this is part two of our discussion, right? Where we're trying to understand the concepts of reinforcement learning through human feedbacks uh, using the TRL Transformers for Reinforcement Learning library from Hugging Face. Okay. So remember, we're trying to build a GPT that generates spam. So it's something related to cybersecurity, not defense, but actually offense, right? So use with what is the expression? Use with care or something like that. All right, with extreme caution. All right, so but you can see hopefully this gives you an idea that AIs are just, they're, they're gonna have a huge impact. All right, so we've talked about everything. In the first discussion, we basically talked about the GPT part, bringing in several concepts through the TRL, the PPO trainer. Now, as I said to you guys, we are, and I think maybe I should bring up that example I have. Is it this one? Yeah. So this example, right? So I started with this diagram and I'm going back to it, right? So we had a GPT-2, our distilled GPT-2 gets in a query, produces some output. Then those two are concatenated. If you notice, query and response, the movie is really great. And they're going to be fed into another model, a third model, a big one too, possibly, in this case, a Distilbert type of a thing. And this we're going to be using to produce rewards, and that's the feedback that goes into our model. So in a reinforcement learning environment, like a game, you're playing chess and you're getting rewards. You want to maximize rewards, right? So the more rewards you get, the better you're playing, right? So it's kind of how it works. So essentially, so now we've addressed a lot of this in the first part. In this second part, we're going to address the BERT model. So I'm going to go ahead over here, BERT reward model. I'm going to go back to my, and I can close this now. I'm going to go back to my code and start bringing in the BERT model. So if you remember on last week's discussion during transformers, we went over something called the pipeline. So there was an abstraction that allowed us to define like a class that we want for a specific model, and then we use it for prediction. It did a lot of the heavy lifting. You can use that here. It doesn't really matter if it says sentiment analysis. It just processes the data as we need it, so that's fine. So notice over here, we just have the device that's going to be, something like a GPU. So if PPO trainer, if device 0, if torch CUDA is available, else CPU, right? So hopefully you're doing this with a GPU. And then essentially here, we create something called a sentiment pipe, right? An object, something, which, as I said, this is just, the name doesn't matter. We're not actually doing sentiment analysis. We're going to be doing spam, not spam detection, right? So that's what I want you to understand. So this is just for convenience there. What matters here is this one. The model is E. Alvarado, and then from Hugging Face, they created a model called a BERT fine-tuned phishing. Do you see what I'm saying? So this is what homework 2 is about, right? So homework 2 is I want you guys to spend time just looking for these models. Start thinking, so that way you will see what's out there, and then that'll give you some ideas into when you do homework 3, what kind of a GPT you want to create, right? Beyond like the toxicity, the funny one, the sentiment one. I want you guys to be creative and try to come up with some interesting GPTs. So in this case, David Higley, he picked a fine-tuned model, a BERT, that's already trained and fine-tuned to say if something is phishing or not. So let's see how this one works. So let's go. We need to, again, load it. So that might take a while. There it is. I need to move this. All right, so it's thinking there. All right, so as you can see, it's trying to download the model. We want to, before we run it, we just want to do a demo of how it works, okay? So that's going to be the idea. So, and this is actually really important. So I want to make sure I stress this part for you guys. So I will add this code here, and I will add this code here. So you can see that's a really big model because the GPTs that I downloaded before, I think, downloaded much faster. And this might, so I think one thing that I had done in the past, I had done the sentiment analysis with a regular GPT and just some classifier I found online. And that ran fine on my 2080 Ti or whatever. So, but I could not get this to work with a normal GPT. I had to use the Distilbert. So it makes me think. So it's how many gigs is that? 1.34 gigs, right? Yeah. So just think of that. It's like 1.5 gig, another 1.5 gig, 1.34 gig. And if you start using llamas, it might get a little bit bigger. So definitely consider the distilled models. But anyway, it's downloading. So I guess this part we can do on the Jupyter Notebook. So while this is downloading, so let's take a look in the Jupyter Notebook at the results. So I gave it the text. This movie is really great. So remember, we created a pipeline with the BERT fine-tuning for phishing model, right? So we have that as a classifier, right? And it provides logits. So in this case, the logits are essentially these two, right? So it produces a vector of size 2 where one column is benign and the other one is phishing, right? And remember that a classifier produces a probability distribution that should add up to 1, right? So that's essentially kind of the idea there. So this provides some kind of a score in this case, the way that it was trained, and it says benign or phishing, right? So the movie was really great. So produces the sentiment, and it says phishing -5, benign 6. So you could argue that it is correct, right? It thinks that it's more likely to be benign. Does that make sense for you guys? All right. Then you do the next one. This movie was really good. Please kindly provide me with $500 immediately to receive your dime. All right. So that's probably phishing. And you can see that the classifier actually said benign -3, phishing 3.57. So this is already a really good classifier of reading text and telling you what is phishing versus what is not. Does this make sense, guys? Yeah. So essentially, that's the idea. Now, you want to use this then, this function to make the text as something. So you need to decide here, do you want to make it more like phishing or more like benign? So pay attention to this when you're doing your project, okay? If you choose that you're just going to, so think of, let's say that this output test, right? This output test has oh, you can see that here. I did it here. So output test is a vector of 2. If I do output test 0, then essentially I'm just grabbing that first value. If I do output 1, then I am essentially always grabbing that value. So this is important because you use one of those, and your choice determines the outcome of your GPT. You could either make it more benign by using output 0, or you can make it more like phishing by using output 1, because at the end of the day, this phishing goes up the more it looks like phishing. And that's actually what you want. You want that to go up, and so it works as a reward, right? The model reads the text and it says, 0.5. so not so much fishing. So then what does the GPT do? It tries harder. The next time it produces another output, it looks at it 0.6, tries even harder, right? And the next time it says fishing 2.7. Ah, okay, that's a better set of weights, and that's exactly how it works. Do you guys see? That's essentially the trick. That's it. This is how we get AGI, right? And ChatGPT and DeepSeek. They got more things going on. Like they've got some nice loss functions and some clever things, but the essential idea is this, except, as I said, that amazingly DeepSeek did not use a model. They created heuristic rules according to their paper, which is, amazing. But anyway, that's the idea. This reward is what the model is trying to optimize, and so the weights are updated based on that. That's the objective of the loss function. Got it? All right. So yeah, so that's the idea. So you can see here for output and output test, and we just print out the score for that output 1 example, and that gives us 3.5. So this is just an example showing how it works. It's not actually doing anything. So you can see it's still downloading because it's a pretty big file. Okay. Did it finish? It's doing that. It's doing that. So I kind of wanted to do all of this live so that you were not surprised when you were actually doing this for your homework assignment, okay? Anyway, I can't really move until this is finished, but that's the idea. Are there any questions or anything? No? All right, making sense. All right, so the next part then, I guess I can copy some code. It's gonna relate to defining parameters, okay? And the training loop. So this, we're almost done, if you notice. Unfortunately, this part is not gonna run on my CPU, but I will at least get to it. And remember, the reason it can't run is I don't have a GPU on this machine. So this is what you would need to run. But I wanted to get as far as here because this is the part that will take a long time. This took me on my 2080 like an hour last night. Yeah, so this took an hour, right? The bigger it is, etc. So on a CP, it runs out of memory, I think, honestly, before it gets to one. But yeah, so let me just add these and then give it a minute to finish. There. Yeah, see, this is still taking quite a bit. Yeah, these are just some parameters, right, of things that kind of you use by default. Let's see what else I can do. And then I guess I can start talking about this code. This is essentially the main loop. All right, so that's going to be it. As you can see, setting up output minimum length, output maximum length, the way that it should sample the data. Then it's got the generation parameters of text. You can see that there, the full parameters. And then here it just starts to, the PPO trainer has loaded the data and it just starts. Remember, the model as it's training, you're giving it a prompt, it's generating a response, the GPT. You take those two, concatenate them together, and then you have the BERT model. Read it, provide a score, use that as feedback, and you update the weights, essentially. Does that make sense? That's the mechanism of RLHF, and that's what's happening here. You grab the data, right? You essentially take the data, get response from GPT-2. So there should be, see here, you take in a query, set of queries, you invoke PPO trainer, generate, give it a query, provides a response, then you just encode those responses, which are, into whatever format you need. And And then here, if you notice, you take the Q and the R, concatenate them together as text, and then that text is given to the sentiment classifier. Do you see that, guys? Make sense? So these are the reward values. And then if you notice, PPO trainer then takes what? Query, response, and rewards, and does the training in the function itself. So that the math is not shown here, but I do have some slides for the math that we will cover. But essentially, take a look. It takes query, the response. You're going to have, obviously, you have the model in there and the reward value. Okay? And this is how they have done it. And then it just creates some statistics. So PPO is this, as I said, the algorithm. All right. So again, I'll repeat. We look at this for loop. Essentially, we grab the data, get responses from GPT. So we have a list of responses. We have the queries. So iterate through the queries, do some formatting. Here, we give the query to the PPO. We generate text. Now we have a query and a response, further processing. Okay. And then here, we concatenate them. And then that's given to the reward, which is our BERT model to produce the final output, which becomes the reward. Okay. Don't change any of this code. You don't have to, for the homework assignment, unless you want to make it better, right? You don't have to change any of this code. You can use it as is, but you need a reward model that's different. That's the thing. And use some other GPT-2 and then just produce the, see the logic of how you fine tune a GPT model to do something specific. All right. So let's see here. It's still going. It's at 56% here. But yeah, so once this runs, mine ran for about 194 iterations. Right. And as I said, this took about an hour. And then once you do that, you can just use this code here, which just takes data from the test set, runs it through the through the GPT before and after, since you have the reference, right? You have the reference, you can use it, and then it's just going to produce this output. Okay. So let's say you give this text to the reference, it produces this. And then you give this text to the new model, it produces this. So if we just read it, it should look more spammy. And also, when we apply the reward function, it should be higher also in the spam domain. But that's what this code should do. You may need to tweak a little bit if like your class has changed from 0 to 1. Any questions, guys? Does this make sense? This is the homework. I do think this is one of the hardest that I wanted to do this topic and just get through it because it's a bit tough. So, but I think if you follow what I've done, and you should be able to run it without issue. All right. I'm eager to see this end. Yeah, and then I think after this just prints out some metrics about the rewards, what the mean, the median. Then you can say, it takes so long to train these models and everything that you want to save it basically to your own computer. So you can do model save, and you save the tokenizer and the model itself for use later on. You can push it to the GitHub if you'd like. And then after that, just this tests the model on one specific item. So indicating utilization. Usage. Okay, so, all right, so it's almost done. Oh, it finished. Great. So you can see this finished. Perfect. So that took a while. Okay, you can see we predict this, the first example, as we said, 6.5, benign. The next example, I guess I didn't print that. So output test. And there, this one is more like phishing, as I indicated, because it says, please provide me $500. Okay, so that does it. Then the last part is just to run these. And now the training where, let's just see if it explodes. But there you go. It'll give you this warning about the attention mask. You can see it's thinking there. Let's just see how long it takes to do like a couple of iterations. Right. So it says here, if you notice, when it's doing the iterations, it gives you, so, you know, one iteration, two iteration, all the way to 194 iterations, 6.11 seconds per iterations, maybe. I don't remember exactly. I thought it took like an hour. Maybe it took less. Yeah, so as you can see, it's training on the CPU, but still no output whatsoever. And that's it. That's as far as I can get with this. But I think if you get to do the other stuff as I did, this part will work as well on your GPU. So this homework assignment, I will create the link in a second. This will be the third assignment, which ties into the second assignment. I literally just want you to use this code is fine, like David Higley's spam code is fine, and turn a GPT of some kind into something. You can try other things, just be aware it's going to be big, right? Those are big models. So maybe what I should have done to improve this is I should have done, now that I think about it, see how long this took. Hopefully that's not an issue. I've distilled BERT for some task, would have been smaller and maybe just as accurate for this. So consider those. All right, yeah, still nothing here. All right, so I guess, does this make sense? Did you guys understand what the homework is? Homework 3, do you understand the process overall of RLHF? Obviously, we have to dig deep into the math and some of the things like the loss function. We'll do that, but do you all, this is how ChatGPT was trained, essentially, right? So that's it. No questions? All right, great. All right, so if there's no questions, what I'm going to do then, seems like you guys understand. See, you can see it's still no iteration whatsoever. So at this point, I think it's okay to kill it. And then you guys would know that you should let it run and then run. Once it finishes and you get to 194 iterations here, literally just plug in this code here and get this table. This is the thing that I want to see, right? When you do your presentations, that's it. In that format, nice like that. And we'll be reading these, and looking at these values, and that's kind of what you want. And it's totally doable. This, you know, this is not a Hugging Face example. You know, David did this, so you can, and several students did. Just find interesting ideas. All right, so I'm going to stop here, and I'm gonna not do that.